and voltage maximums. Well, on the right, it's fed at the center. So right at the center you have a current maximum. At the ends you have current minimum. That's why I say most of the radiation takes place in the center portion of the antenna. So you can have a flat top, and if you don't have room on your property for the last 10, 15 feet, you can drop them down. And you're not affecting the radiation pattern very much. So you can make them drop off. You can even zigzag them to the side and not change it very much. Most of the radiation is in the center 1/3 on either direction from the feed point. In a V, you want to get the top of the V as high as possible. But the voltage is just the opposite of the current. So that's why you get the radiation burns at the ends, because those are the voltage high points. Very low current, but it's the voltage which zaps through your skin and goes to your bone. So you want to be careful of the end of a dipole. It will bite you. And again, those are the equations that you don't need to know.
And in certain conditions, that's the end of the antenna that's glowing.
Well, if you're down near the poles, it will glow even if you're not transmitting.
Yeah.
Here's the radiation pattern over various grounds for your dipole. And he's got it half a wavelength. So this is not that perfect toroid anymore. It's now being affected by the ground. And depending upon the ground, it's affected more or less. So you'll see there is some takeoff angle if it's low enough. You have lost that perfect toroid, that donut shape. And this is a 40-meter dipole. But from when I was writing this software to look at radiation patterns, frequency really didn't matter. As long as you were over half a wavelength above the ground, it didn't matter if you were at 20 gigahertz or at 50 hertz. It really didn't matter. The antenna equations worked the same. Other properties, like the Freeze equation, say things are different at different frequencies, but if you want to look at radiation patterns, the frequency. Something might work at 20 degrees, but it won't work here at 45 degrees.
And people say, oh yeah, you must have worked on E-skip. I'm like, I thought it was all skip. You know,
Oh.
if you're working DX with somebody in the middle of the day on 20 meters, isn't it going to be D or E?
No, D is absorptive. E is the one that might work. F is probably the one you were using. Where was the DX? That will tell you.
Well, for instance, in the early AM on 20 meters, I get Europe.
Okay.
In the early afternoons and evenings on until about dark, I get Japan, Asia, and deep South America.
Okay,
So
you probably
what am I
would-
working with those guys? Because I was just going over the poles to get to Russia, or even over the poles to get to Europe.
Oh,
A straight line from here to South Africa over Greenland.
One time, all of a sudden, the middle of the Saratov, Russia, came in really, really strong. Nice CW fist. Those guys are really good. They need 30 words a minute to get their license. So they're real good. I was working him, and I figured out we're working all the way around the world, dark to dark, because the sun had just gone down. I had lost 20 meters on the daylight side. I worked him 20 meters. He was in the dark, and so was I. So I worked long path. It was really, because I wasn't hearing auroral. I know I wasn't going over the pole. That's really easy, and you know when you're going over the pole.
So how would I know which one I mean, can I look through my logs and go, yeah, that was probably over this, or that was over that, or?
It depends. Are both in daylight? Are both in dark? Then you can normally tell direction.
Well, yesterday's, for instance, was Belgium at about noon, and he was 2-3 hours in the dark on 20 meters. And I was on 20 meters at noon here.
That one's strange. You probably did work him straight and not around, because Belgium's really pretty close.
Yeah,
Saratov is almost
under
on the other
6,000.
side of the world. So it really does depend, and it helps if you can hear what's going on. So you look at how far it is, you look at the various directions you can get to him. I mean, over, because you can go over both poles. I have worked long path over the South Pole.
Okay.
because I knew it was aurora, but we couldn't figure out how in the world I got over the North Pole. We figured you went the other way. I have a V, which doesn't go anywhere. It doesn't move.
So is it just particularly the time of day that you can count on that? Like if they're in the dark and you're in the dark and you're on the same band?
I would say you're going along the dark all the way around.
See, I always thought it would be you'd be on the shortest, well, one of the shortest distance would be light between you, wouldn't it?
The
Well,
shortest,
depends which way you're going, I guess.
the
huh?
shortest path is not necessarily the strongest path,
Okay.
because the deabsorption is really, really strong, and it would kill straight line through of the sun, especially during summer, during our high summer and Europe's high summer. It would be very, very strong during the daytime. But if you work them all the way around the other side of the world, D layer is dead. D layer dies rapidly after the sunset.
Okay.
E layer, it takes a little bit longer, but it's also high enough so it's still getting sun. F layer takes longest. Where did I show you that picture? This one. This takes the longest to die because it's highest. It's, let's see, it's almost 200 miles high. When you use the F layer, one hop will get you, let's see, from here to Chicago on 20 meters approximately, or here to Ohio. Someplace in there. 2 hops means you're in the Atlantic. Another hop means you're in Europe. If you're a little bit lower and you're using the F1 layer, which is down here, see, the F region covers all of this, and it moves daylight and nighttime. In the daylight, it splits into 2 layers. In nighttime, it's only 1 layer, but it's actually a little bit higher and it's a little bit weaker. So you can bounce incredible. When I use 40 meters here, I normally get, Texas is very weak, Colorado is very strong, Arizona is very strong, BC, mid to northern BC is very, very strong. By the time I get into Washington, I'm starting to have problems.
So you can also tell if based upon where all the signals are coming in the strongest. Like Arizona kills me. I hate Arizona, I hate Colorado, I hate Alaska. Those 3 places are all right between around 1,000 miles. The places I hate to see come on because they just watch my waterfall. Those are always the strongest states.
For me, they're really weak. But then again,
But that's on 20 meters.
Oh,
And
okay. At 20 meters daytime, 20 meters night.
20 meters daytime, they kill me.
I only work HF in the morning and at night.
I don't want to keep you too long, but I'd really like to get a better grip on the, how to tell which way I'm going.
Well, the best
What
thing
I'm
is to
using.
keep listening and get call signs and look them up.
Well, I look them up every time I get a call sign.
No, look at everybody around them. Not just the guy you're working, but get as many call signs as you can.
Okay.
Okay. So these are the various layers. F is day and night skip, we covered that. D is 40 to 60 miles high. It definitely attenuates RF. So you know that if it's, especially in the summer, in the winter it's not as strong because we're not getting the direct insulation like we are in summer. But you can tell that from here to New York, on the daytime, it's not really possible. If it happens, it's very, very lucky. E layer is something that we don't really use except certain frequencies. Tropoducting is in the E layer. Sporadic E's is the E layer. The F layer is what is basically HF. So that's why you get the radiation burns at the ends, because those are the voltage high points. Very low current, but it's the voltage which zaps through your skin and goes to your bone. So you want to be careful of the end of a dipole. It will bite you. And again, those are the equations that you don't need to know.
And in certain conditions, that's the end of the antenna that's glowing.
Well, if you're down near the poles, it will glow even if you're not transmitting.
Yeah.
Here's the radiation pattern over various grounds for your dipole. And he's got it half a wavelength. So this is not that perfect toroid anymore. It's now being affected by that
antenna, and the manufacturer said